Hello everyone. In this video I'm going to be looking at simplifying, in this case multiplying, complex numbers. So my two complex numbers in this case are 13 plus 2i and 2 minus 10i. And as it's set up, I want to multiply them. Now oftentimes this is instructed by saying simplify, or sometimes multiply and simplify, or sometimes just multiply. Either way, one of the things we have to know before we do this is a particular substitution. If at any point we have ourselves an I squared, resulting from multiplying two i's together. Just as if I said x times x gives me x squared, in the same way, I times I gives me I squared. Even though I is still defined as the square root of negative 1. I squared then is defined as just negative 1. Think of squaring the square root of negative 1 and we're left with negative 1. So anytime when we simplify complex numbers, if we come across an I squared, we're going to immediately substitute a negative 1 for that. Now in my example here, I'm going to simplify by foiling. First outer, inner, last. So first I'll do 13 times 2 to give me 26. Now 13 times 10i to give me a negative 130i. 2i times 2 to give me a plus 4i. And then finally, 2 times negative 10 to give me a negative 20i squared. Now I want to combine my like terms. First of all, I can see that negative 130 and positive 4 are both common terms, or like terms I should say. They both have an I as a variable, or looked at as a variable. So negative 130 plus 4 gives me a negative 126i. Of course I have my 26, but now we see an I squared, just as I mentioned before. So, as I said, whenever we see an I squared, we substitute with a negative 1. So this is really saying negative 20 times negative 1, which would in turn make it a positive 20. Because again, negative times negative makes it positive. Now I can combine my 26 and 20 as they are like terms now, and I'll come out with an answer of 46 minus 126i. And this would be my final answer. Let's try another one. This time, I'm asked to simplify, and I'm essentially distributing. I'm taking my 3i and multiplying it to both my terms. 3i times 2 gives me 6i. 3i times 7, or negative 7, gives me a minus 21i squared. Again, I have I squared because I times I. Now 6i remains 6i. I have nothing else I can combine it with. However, my I squared makes this minus 21 times a negative 1. Negative negative makes this a positive 21. Now here, 6i and 21 are not like terms, so this is my final answer. I can't combine it any further. Lastly, let's look at a problem such as this. Again, I'm asked to FOIL, so I'll say 3 times 3 to give me 9. 9 times negative 7i to give me minus 63i. Or excuse me, minus 21. Saw that 9 and got confused. So minus 21i. 7i times 3 to give me a positive 21i. 7 times negative 7 to give me a minus 49i squared. In this case, my negative 21 and positive 21 cancel out completely, so they add to 0. So I can just get rid of them. Still have my 9. Like before, negative 49 times negative 1 to make this a positive 49. Now I can add 9 and 49 to get a final answer of 58. you may recall that the way this is set up, this is reminiscent of difference of squared factoring. These are actually referred to as conjugates. And in the case of i's, with complex numbers, I end up with just the whole number 58 and no more i's present. Either way, when we multiply I times I, we get I squared, and we want to substitute that with a -1. And then combine our like terms.